Hi everyone, these are the notes for LT4. Your task in LT4 is to calculate the average acceleration for linear motion. That would be straight line, up, down, left, right, diagonal, but it has to be linear for where we're at right now with our mathematical abilities, we should say. So we can't get into trigonometry, so it has to be straight line motion. So LT4, calculating acceleration. A little bit of artwork to start with before we throw our 2-column notes up there. Kind of the whys we're doing this. Think about a skydiver. Okay, so I don't know why that parachute's attached to his head. I don't think that's a good idea. But when somebody jumps out of an airplane, the Earth's acceleration is 10 meters per second squared. So that means after 1 second, they're falling 10 meters per second. After 2 seconds, they're going to go 10 faster. Okay, so this squared things means 10 meters per second every second. Every second you fall, you go 10 meters per second faster. So you would be falling at 20 meters per second during the second one. The third one, 30 meters per second. Think about the distance you would fall. When you first jump, you're only going to fall about 10 meters. But in that next time interval, you're going to fall an additional 20. In that next time interval, you're going to fall an additional 30. You are accelerating towards the ground. Okay, you're changing motion very drastically. People that are into skydiving are also usually into these things. I'm kind of a wimp, so I am not. But a lot of people like roller coasters. Cedar Point banks on that. And if you think about it, if you've been on a roller coaster, that first hill is usually the biggest. That's a potential energy thing. But as you come down, your velocity is increasing. Okay, so as you're at this point up here, as you come down that hill, you're seeing an increase in velocity. So that's a positive acceleration. When you're going up this hill, you're going to see a decrease in velocity. That's a negative acceleration. We know in corkscrews, okay, look at the corkscrew, or any loops you have, you are constantly changing direction there. And we know that a change in direction is also a type of acceleration. All right, so the terms of why we do this is because anything that's changing motion is accelerating, so it happens all the time everywhere. All right, evidence interpretation. Thinking back to LT1, that vocab target, we had just a straightforward definition of acceleration. It is a change in velocity over a period of time. Okay, a change in velocity over a period of time. You might want to pause this video, and get out your formula sheet. Because the way that we write it in the notes, I would also write it like that on your formula sheet. Because remember, you can take this to the stations when you take an LT. You can use it on the unit test. You can use it on the final exam. This is your friend. It might not look very friendly, but this is your friend. So the formula we're going to use is final velocity minus the initial velocity, and we divide that by the change in time. So what I mean by final velocity is you'll see story problems where you're looking at a snapshot of a situation. And so the final velocity would be like the end speed that they're going. The initial would be like at the beginning of the story problem. How fast are they going? And then the time component is how long did that take? Now the rest of the notes are really just working through problems. And so if you're in class, you received this. If you were absent, you can pick it up from me. But the story goes, you are trotting on a horse at 10 meters per second when you decide to break into a 17 meter per second gallop. It takes you 2 seconds to achieve this. What is your acceleration in meters per second squared? Don't let that get in your head. That's just the unit for acceleration. You won't type that into Moodle anyways. It doesn't mean you square the answer. Okay, it's just the units. And then round to the nearest tenth like we almost always do. So if you think back to LT2, which was average speed, remember I said it's really useful to label stuff. So you are trotting on a horse at 10 meters per second. That's the beginning speed. So we're going to call that the VI. At the beginning of the problem, you're going at 10. You decide you want to go faster. So at the end of this problem, your final speed is 17. 2s, 2 seconds. That's your change in time. So now all we do, acceleration is VF minus VI divided by how long that takes. So we have 17 minus 0. We divide it by 2. Okay, this is in meters per second. This is in second. That's where that squared comes from. When you divide, it squares the units. It doesn't matter for this class. So 17 minus 10, sorry. 10 was the starting speed. That gives us 7 over 2, which is 3.5. We need the tenth, so here's our units. But into the Moodle box, we would just type 3.5. And just kind of use some common sense. We're getting faster, so we should end up with a positive number, okay, if you're gaining speed. Now for number 2, you're galloping at 17. So end of this problem, I'm not very creative. The horse you are riding has had enough. He decides to come to a screeching halt in 0.75 seconds. That's pretty quick. So assuming you do not go tumbling over his head, what is your acceleration? Now if you've ridden horses much, you know exactly what happens here and you know how this feels, all right? And you may have went tumbling over his head. But we're going to pretend that you are one heck of a rider and you stayed on. So, same formula. Something different though this time is we are slowing down. Okay, we are going at 17 and we are coming to a halt. A halt is a stop. That's how fast you're going at the end of the problem. So our final velocity is 0. This time our initial velocity is 17. And our change in time, 0.75. I'll put it over here because I don't want to get it all clustered up there. So, most common mistake is people see a 0 and I'm just going to ignore it because a lot of times in math class, zeros don't matter. Zeros matter. Because if you think about it, if we have to slow down and our final speed is 0, we should end up with a negative acceleration. So we subtract that original 17 and we divide it by the time, which is 0.75, 0.75, doesn't really matter. Okay, so I don't know if you can see this under here, hopefully. Yep. So 0 minus 17 gives us a negative 17. That's important. We divide that by 0.75 and we get this negative 22.6, and 6 is repeating. Remember, we need, we need the tenth. So we had this, okay, with a little repeating symbol. We have to keep this value, that is the tenth spot, but this, because it's 5 or above, it says to kick that up. So into Moodle, you keep the negative sign. It's right diagonal from the P character on the keyboard. So negative 22.7 is what you would type into Moodle. Okay, negative 22.7. All right, so what I want to do in the notes, we're going to do one more of these together, and we'll have it here as an example. And because remember, final exam time, you can use this. So the things that you would want to label when you're taking that final exam and when you're taking every other assessment, since everybody can use this on the final exam. This time, we've got a skateboarder, and they're cruising here, they're riding at a velocity of 7 meters per second when a porcupine runs out in front of you. I'm struggling this morning. Okay, so right there, you're riding at 7 meters per second when a porcupine runs out in front of you. That has to be your initial velocity is 7. Assuming you don't want quills stuck in you, you decide to bring your skateboard to a stop. Stop means the final velocity is 0, and it takes 1.25 seconds. So the change in time, 1.25 seconds. What is your acceleration? Please round to the nearest tenth. So we have a final velocity of 0. We have an initial velocity of 7 meters per second, and our change in time is 1.25 seconds. Acceleration, we're slowing down. This thing needs to end up negative. So 0 minus 7 divided by 1.25. So we're going to go 0 minus 7. Hit enter. divide it by 1.25, and we get something pretty. Don't have to worry about the rounding. It's already just to the 10th. So your acceleration is negative 5.6 meters per second squared. But again, all you would do is type in the negative 5.6. And that is LT4. Making sure I'm not missing anything. Nope, we're all set. Good luck.